Hello, my name is Anthony, and this is my Physics Lab 2 on line charges. The purpose of this lab was to compare our previous lab where we just considered the tape as just a point charge with the line charge model in which we use several point charges, or I guess DQs, on the tape, both bottom and top, and compare the forces on each of them to produce a combinant force on the top tape and see how that's different from how it is in the point charges. The fundamentals and models that were important was the law of superposition. Of course, since each DQ from the bottom tape has to combine on one DQ from the top tape for each DQ on the top tape. I also had used Coulomb's law. That's how I calculated the force. And Newton's second law was important because the gravity has to counteract the force of electric for the tape to be actually floating. So, being able to set those formulas equivalent was, important for this lab. Just a preview of my results. On the line charge, the total charge I got was 4.005 e to the 9 coulombs. That's compared to my 4.8786 e to the 9 coulombs for my point charge, which surprised me. I wasn't expecting the line charge model to need a lower charge to propel the tape, but that was the result I got. On my coding, I first want to point to how I got my electric field. This was mostly just copied over from my first lab. It has the constant, the charge of the tape, the magnitude of the displacement squared, and then the norm of the displacement as well. And that's what we used for each DQ from the bottom tape for a DQ on the top tape. And in this, it's a little hard to see. I have to scrunch this into a smaller frame, but there's the formulas where I use to calculate each bottom DQ's force on the top DQ using just a nested for loop. The assumptions that we had to make for this experiment was that the tape was treated as a line of charges. Even though this should be more accurate than the point charge model, a tape is a 3D object. It has length, width, and height. It has charges on all of those parts and not just in a straight line. And the charges within charges anywhere are going to interact with each other. However, we ignored the fact that the charges within the tape might have effects on the other charges within the tape, retarding the results somewhat. That was just ignored. And also, we only used like 10 or 20 or so. I used a couple to figure out which one I wanted. But however many, whatever I said my n equal to for my line charges is not indicative of the amount of charges that would be on an actual tape. There's simply many more individual charges on a tape than like 10 or 20. Air resistance was negligible. That was not put into my coding anywhere for my formulas. And like I was saying before, the amount of DQs might not accurately represent the amount of charges on the tape. The what if question using a point charge model appears to yield a larger necessary charge to lift the tape. The reasoning why I believe this to be the case is likely due to the differing displacements between the DQs from the bottom and top tapes. Let's say you had like the top tape, the most leftmost DQ, and then you have the bottom tape's most rightmost DQ, right? The displacement between those is just different than the displacement between just a point charge is going directly up to another point charge. It's a further distance, just in absolute terms. And, differences like that would likely, lead to the differences between the two charges. Thank you very much.